Good morning, everyone. So I wanted to go over some of this information with you asynchronously because um, you're not going to have me available for the whole class period. I'll be there for about the first hour, and I will actually go through stuff in class. But I also wanted to create this video so people can go through the information a little bit asynchronously. And it might seem a little bit disjointed because I did create separate videos for actually doing the circle and squares, pattern making, as well as how we actually utilize the flippy do on actually generating a base conversion from decimal to binary. Uh, so I apologize if it seems a little bit weird as you're going through the videos, but as always, you can reach out to me or you can talk to Miss Stevens there in class and everything, and we'll be sure to try to clear up any hurdles that you might be dealing with as far as how the information is getting to you. But so initially, when we started out the class, we were talking and using these circles and square uh, pattern making, but the goal was binary numbers, right? Let me go through this slide deck. I didn't generate it, so it might seem a little bit weird as I go through the information, but I wanted to 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 utilize the resources that I have here on code.org. So visually, we give you these circles and squares and everything because we want to kind of have you go through the process of when you have a choice, like you have the two possible patterns, but it gives a choice of either having one or the other, right? So uh, we have we have this card, right? That either you have a square or a circle that you can put into any given position, right? So two place values for any one single place, right? Uh, so so if we go in these two place values, right, and we go through the process of actually seeing how many possible patterns, if we have two place values, you'll notice that we can actually create four different patterns, right? Because since there is two options, as we switch out and we like in the first place we put either a circle or a square, and then in the next place either we have a circle or a square. It basically gives you the ability to actually have four different possible patterns. Conceptually, if we go through that, that actually says um, mathematically we could go 2 times 2, and that actually gives us four possible patterns, right? If we go three place values, and in the other video that I showed, where we actually go through that process, um, we find out that if we use three place values, when we go through using the possibility of only having a circle or a square in any of those three place values, we'll find out that we can make 8 possible patterns. And this is actually making a little bit of a sequence to where as we add another place value, we're actually just effectively multiplying by 2. So as we go through, each time we step up another place value, it actually just multiplies by 2. So when we have three place values, we only have the possibility of actually creating 8 different patterns, right? So instead of 2 shapes, what if we have 10 shapes, right? Uh, and the reason that they're asking this question is so anytime we actually write numbers, like let's say we're doing algebra or we're doing geometry, like Like, what we're actually doing is we're creating this numerical system on which we actually can do calculations and stuff like that. And yes, what they're showing you here is, instead of shapes, we're actually using digits, right? We're using the 0 through 9, and these are 10 different shapes, but we actually have kind of place values. And in this numerical system, we call it decimal, because it actually stands for the 10 different shapes or values that we actually place in each placeholder, right? So if we have two places, right, how many possibilities can we actually have? And if you already guessed it, we actually have 100 possibilities, because basically we're counting up from 0 all the way to 99, which gives us 100 different possibilities. And then they ask the question here: where is this heading? So the whole concept is, in computer language, when computers are actually talking to each other, they actually use what's called the binary system, right? And the reason we want to talk about binary is, using these two shapes, actually what is actually happening is we're actually using ones and zeros, right? Ones and zeros, all these ones and zeros that are happening, is the way that that the computers are actually processing information. But realistically, what's actually happening inside the computer itself is, these ones and zeros. The 0 is actually a low voltage, and the 1 itself is a high voltage. So actually, what's actually happening is electronic voltages are actually being passed through the computer to where anytime you see a 1, it's actually operating transistors or a flip flop to where it's passing a high voltage. So maybe it's making the electronics do something different than not passing any voltage at all. So it's kind of like a switch. It's like turning on or off, again, kind of going through that process. So conceptually, when we talk about binary, physically something's happening within the computer to where it's having processes that are going through and going on or off, right? But we'll go back to the counting, right? So going through that process of using the circles and squares, if we have 3 places, we actually go through and have the 0 or 1, and when we have 3 places, that gives us 8 different possibilities. So now, kind of going through that initial pattern of going through and saying 3 places, we have 2 options in each one. We want to create this thing called a flippy do, and it's going to make it a little bit easier to basically process and calculate binary numbers, if you actually set up this flippy do, because it makes it a little bit easier to kind of understand it conceptually. We start out with the circles and squares to give you kind of a visual way to look at it, but this is the calculation part of it. So like if you're adverse to actually doing calculations on a regular basis, it makes it a little bit easier to conceptually start with the circles and squares, but ultimately it's all about how the computers are talking to each other through computer language. So if you're looking at this slide right here, you'll notice that as we go through those places, right, what we're actually doing is we're taking the 2 and putting an exponent to it, to give you the amount or the value in decimal of what's actually happening in each of those places, right? So looking across the top there, you'll notice that in that first place, to the 0, that's actually giving you a value of 1. So if we actually have a 0 there, it's giving you no value, but if you put a 1 there, it gives you a value of 1. And then in the next place, like as we move to the left, in that next place value, so if we're doing 2 places, right, we actually have 0 and 1. So like if you go through and write the 4 different combinations, 0 0 equals 0, 0 1 equals 1, 1 0 equals 2, and 1 1 equals 3. But you can't actually show 4 with just 2 places in binary, because the actual value of 4 actually has to go to the third place value. So you'll notice that the 2 to the second power is the value of 4. So if we wanted to represent 4 in binary, it actually would be 1 0 0, and so on and so forth. Okay. So now this is a huge concept right here. As the computers actually process number, each place value, right, the 0 or the 1 is called a bit. So anytime we talk about a bit, that just means one place to where we're talking a binary number, and that's that 0 or 1, but it's 1 bit. And then the term byte that you'll hear talking computer language a lot of times, a byte is actually taking 8 bits collectively in a sequence, right? So a sequence of 8 bits together is a byte, right? So looking at this slide here, how would we represent those decimal numbers in binary? Just kind of going through the process of breaking it down. It shows that the 7 represented in binary, if we actually used our flippy do and went through. So if you go through the whole process of starting from left and going all the way to the right, you start at the highest number, and if you can't actually subtract that value out of the number that you're trying to convert from decimal to binary, then you can't actually utilize it. And if you cut to the video where I actually do the flippy do process, it'll be a little bit easier to physically see what I'm talking about. So I'm going to skip this slide right now and see if they actually give me a little bit. So see, it drops down some information there to show you like what the actual conversions are. So I could talk about it a little bit. So as you break down the 8 bits there, so like as we transition the 7 to the binary number, that first place value is 128. We can't put 128 down because it's bigger than 7, so that goes to 0. Next one is 64. That's a 0 because 64 is bigger than 7. The next place is 32, but 32 is bigger than 7, so that's a 0. The next place is 16, but the 16 is bigger than 7, so that's a 0. The next place is 8. 8 is bigger than 7, so that's a 0. But the next place is 4. So since we can actually put a 4 in there, we put a 1 for that place, right? Subtract 4 from the 7, that leaves us with 3, right? We go to the next place. 2 is less than 3, so we can actually represent a 2. So we put a 2 there, right? And take the 2, subtract it from 3, and that actually gives us 1 left. So the 1, yes, we can represent 1. So 1 minus 1, that gives us 0. So when we actually convert that to a binary number, as the bit, the byte, showing the byte as a binary number representing the decimal number of 7. 0000111 is the actual binary representation of 7. Go through that same process when we're actually doing the conversion of the decimal 20 to binary. Go through that same process. First place, 128, too big, can't do it, put a 0. 64, too big, put a 0. 32, too big, put a 0. 16 is smaller than 20, so we'll put a 1 for the 16 place. Subtract 16 from 20, and then that leaves us with 4. So go to the next place. 8 is too big, is bigger than 4, so put a 0. Next place is 4. A 4 is same as 4, so 4 subtract 4, 0. So that leaves us with 0. So, and we put zeros in the other places so we can actually have them as placeholders. So when we represent the decimal 20 as a binary number, that's 00010100. And you do need the zeros to the right, because just like when we're writing numbers in decimals and you use zeros as placeholders, you also have to do the same thing in binary. So your bits are aligned with what place value that they need to hold, right? So if we actually do these conversions down here at the bottom, represent these binary numbers in decimal, we can go through the process from actually right to left to make it a little bit easier as we kind of walk up, right? So if we're looking at this right here, right, we can go 0. This first place right here is a 1 value. So there's no 1, but we do have 2. So we do have 2. This is 0, 0, and then this is the 4 placeholder, 8 placeholder. This is 16 placeholder. So we have 2 and we have 16. So this should be 18, right? So if we wanted to represent this as a decimal, this would be 18 in decimal from this binary number. And then this next one right here, if we wanted to convert this binary number to decimal, we would actually take this and go 1 plus 2, which is 3, plus 4, which is 7, plus 8, which is 15. 15 plus 16, that should give us 31. So this first one is 18, and this next one is 31. So, and we can see that we were correct. So just to kind of reiterate, our byte is actually set up to where we talk about 8 bits gives us a byte, right? Now, to expound upon that, because I do come from a little bit of an old school, I wanted to actually talk about a little bit more of conceptually this vocabulary that we got going on. So they got nice little pneumatics there and everything. Bits U total to 8 is the byte. But one thing that I actually wanted to talk about is giving you a little bit more information on kind of this whole concept of computer language. So in the old school, before when we were learning how to basically break down computer language and everything, we used to code in what's called assembly language, because the way the computers would process information and going through giving the bits and everything, we would combine them in different ways. So the byte itself being 8 bits, we would talk about different numbers in which the combination of 4 bits is actually a hexadecimal number, and you can actually do hexadecimal conversions to where we actually do use letters in that sense. So as you go through the process of writing a hexadecimal number in any given way, you have to use, instead of 10 different possibilities, you have to use 16 different possibilities. So we add letters at the end of that as you go through. So when we talk about hexadecimal, starting at 0, 0 in a place value is 0 all the way up to 9, 9 being 9 place value. But if you wanted to represent 10 in that place value, you would write A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F, right? So when we talk about hexadecimal, you use A through F to add on to that, so you actually have 16 different possibilities whenever you write in a single place value and giving 16 different possibilities. So we start using letters. And then in given assembly language, we would actually take the byte, since it's 8 total bits, and each set of 4 bits is actually a hexadecimal number. So anytime we talk about a byte, since it's 8 bits and a set of 4 actually gives you a hexadecimal number, we would also write our assembly language in hex pairs, because each 4-bit number, or each 4 place valued binary number, can be represented by one hexadecimal number. We would take a byte and represent it as a hex pair, because you can take the 4 values and convert each of the 4 bits into a hexadecimal number, and actually create hex pairs, and then be able to write your assembly language in the sense of doing hex pairs as you go through that process. And I know this is a lot of information to kind of be thrown at you, but I just kind of wanted to put it down for you real quick, just so you can start thinking about that kind of stuff. Now, if you need a little bit more information on it, I will actually go through and kind of write this up and do a separate video to go through to help you with that a little bit more.